Assalamu alaikum wa rahmatullahi wa barakatuh. So again, this is Dr. El-Moursy, and we are in the DLD lectures. Uh, right now, we have finished lecture number 15, and we are approaching or going to the next lecture, which is lecture number 16. In lecture number 16, which is the last lecture for the chapter 3, to close anything related to the basics of the DLD design. We have learned the three basic logic gates, the AND, the OR, the inverter, and we also built two complementary gates, logic gates, which are the NAND and the NOR, and we have motivated you enough for their advantages. In class or lecture number 16, we are learning also a new logic gate called the XOR. As we have indicated before, only the basic logic that is needed for any DLD design are only the three basic logic gates: the inverter, the AND, and the OR. NAND and NORs, we learned them, and we have actually motivated you enough for why we are learning them, because actually they give us a head or an edge in the sense that they have a kind of a magical capability. Those two gates, the NAND and the NOR, have a magical capability to implement all of the circuit using only one type of logic, which has an advantage in the manufacturing. The last logic gate that we are learning today in lecture number 16 is the XOR. And again, this is not a basic logic gate. This can be compensated with others. However, the XOR and also another complementary logic gate called XNOR are not two basic logic gates. They are have applications. In some particular applications, it will be much better for you to implement the circuit using the XOR and the XNOR. So whenever possible, when you have the scenario suitable for the XOR and XNOR, it will be preferable to use them. However, you can live without them. Although we can live without them, we want to learn them. We need to know what they are doing and how can we utilize them. Because anything for some certain advantage. There is an advantage for using the XOR and the XNOR, replacing the basic logic gates, the AND or inverters, and the two complementary NAND and NOR. So